VLSos here. This is a video lesson on factoring and canceling. I'm going to show the strategy of factoring and canceling by working several examples. In this case, we've got 4x plus 3 divided by x minus 5 times x minus 5 over x plus 3. I'm multiplying two rational expressions. These are complicated fractions. Fractions that are based on algebraic expressions both in the numerator and denominator. And I'm multiplying, so I could see this as groups multiplying other groups. I can use parentheses to group these things, the 4x plus 3 and x minus 5, so that I only have one fraction bar. And when I do, if I didn't see it before, I can see now that I've got one group in the numerator and one in the denominator that are the same factor. And since everything is factors, I can cancel the common factors. Common factors are ones that are identical. When I cancel them, they turn into 1. And I don't have to show multiplication by 1 because multiplying by 1 doesn't change the value of what we multiply by. In this case, this simplifies to what remains 4x plus 3 all over x plus 3. And we have to be careful because if we're asked to simplify, we need to continue to do so until we have the simplest result left over. And if we're looking at this and thinking that we might still want to simplify, we see an x plus 3 both in the numerator and denominator, but we can't cancel the x plus 3's because x plus 3 is not a common factor in both the numerator and denominator. For x plus 3 to be a factor in the numerator, I would have to factor out the 4, and this 4 factored out would not leave 3 as the remaining factor. It would change it. X plus 3 is not a common factor, even though it kind of looks like it at first glance. So we can't cancel it further, and this is as simple as it gets. Let's provide another example. X plus 2 divided by 9x minus 1, all divided by 2x plus 1 divided by 9x minus 1. In the beginning, I can see that I've got two groups in two different fractions that are the same, but they're both in denominators. It's not appropriate for me to cancel out two common factors in denominators. However, I am dividing fractions. And the first step when looking at fractions that are being divided is to convert it into something that is much easier to deal with. We're going to convert the division into multiplication by taking the reciprocal of what we're dividing by. Reciprocal means we switch numerator and denominator. These are equivalent. We can turn division into multiplication by taking the reciprocal of what we're dividing by. And now, just like before, I can think of this as a single fraction bar and use parentheses to group the things that I'm multiplying. These are all factors now. Each group is a factor. And we do have the common factor 9x minus 1, which will cancel out, leaving 1, which we won't represent. And what's left is x plus 2 over 2x plus 1. It's worth slowing down and thinking if we can factor or cancel any other common factors. There are no common factors left to cancel. These 2's will not cancel each other because the x plus 2 is not in factored form. It's in distributed form. We're summing x and 2, not multiplying them. Same thing with the 2x plus 1. Not in factored form, we can't cancel a common factor. Let's proceed with another example. In this case, y minus 2 all cubed over 3y times y plus 5 over y plus 2 times y minus 2. If I'm multiplying two fractions, I can think of that as one fraction bar, group the things that I'm multiplying just as before, and now that I have all factors, all the groups are multiplying each other, I can look for common factors. This cube means that the y minus 2 factor is represented 3 times. Y minus 2 is multiplying itself 3 times. So the y minus 2 represents 3 factors of y minus 2, and one of them can be canceled in the denominator. This y minus 2 factor can cancel one of the 3 here. To show that, I can reduce the exponent to squared instead of cube. I've canceled out a y minus 2 in both the numerator and denominator. What's left then is the y minus 2 squared, y plus 5, 3y, and the y plus 2. I'm looking at more common factors to cancel. I'm not finding them. We've got lots of factors here, but none are the same. The y minus 2 is not the same as the y plus 2. The difference between addition and subtraction is significant. One more example. Three z plus 15 times z to the 4th divided by z cubed and z plus 5. In this case, I have one fraction. I have factors. I've grouped the 3z plus 15 and the z to the 4th, z to the 3rd, and z plus 5. If I move the z to the 4th in front, doesn't matter the order in which I list the factors, but if I put it in front, it might be easier to see that I've got 4 z factors. Z to the 4th means z times itself 4 times. So that's 4 individual z factors. 3 of them will cancel with the 3 z factors that I have in the denominator. I can cancel 3 common z factors, which leaves a single left over in the numerator because there's one more in the numerator than the denominator, which leaves in the denominator z plus 5 and in the numerator 3z plus 15. And I can continue to look for things that I might be able to cancel. If I see z plus 5 as a group, it doesn't look like the group 3z plus 15. However, I can factor out a 3 from 3z plus 15. And I ought to try to do so. When I do, the z is still there. I'm factoring out a 3, and what remains of 3z after 3 has been factored out is z. What remains of 15 after a 3 has been factored out is a 5, which now matches the denominator. When I cancel out the denominator with a common factor in the numerator, there's nothing left in the denominator, but we don't make it 0. The denominator, when we cancel, becomes 1. Division by 1 can be ignored because it doesn't change what we're dividing. And what's left is the 3 and the z. Remember that when you are simplifying, you want to continue to try to simplify as much as you can until you can't simplify anymore. And it often takes several steps to get to the final simplified answer.